I am the Eclectic Doctor. My interests are various, and where they intersect is where I love to be. In our last video, I made the comment that a computer can only do two things: store a value and read a value. Everything is built up from those two actions. For example, a computer program is a sequence of instructions that we read in from memory in order to execute. If you are interested in this idea, I have a video on the Marie Architecture Simulator that gets into how the CPU of the computer actually works, and I'll link it here. I want you to understand that a fundamental capacity for computers is the ability to change which instruction is executed next in our program. We call this branching. If you remember back to our flowchart, you can see that in order to accomplish complex tasks, the computer needs to be able to branch in its code to various different locations, sometimes even going back to re-execute code that has already executed. This is because every CPU has the ability to read the instruction at the next location in memory. And the instructions have the capability of changing what instruction will be read next, or what instruction we're going to point to next. So when I started programming in the late 70s, it was at a computer camp at the Nova Scotia Teachers College. I remember how we had to include the line numbers with our code because this was how we could create branching in our code. The code looks something like this. It's just an example here, and I wanted you to see the goto statement in here. Goto took an instruction line number and made that the next instruction that the program would run. In the example, it simply kept prompting the user for a response until someone pressed a Q as a response, in which case the if will fail and the next instruction, instruction 70, will execute by gracefully terminating the program. Thankfully, we've moved past line numbers in our code. We've done this a long time ago. But if you look at what the CPU is doing, it is basically a goto with an address, the address of the instruction that we want to jump to. And we've already seen this with the code in our code blocks video. The web page in our web browser displays our HTML page. When we trigger the on-click handler of the button, it says find the code that starts with combine and run it. So right down here we have this. I mentioned that this was a block of code, and basically what we're doing is we're saying that when you have a button click, you're going to go and look for the code that starts with the word combine. And we had to write that code. So we wrote that code here in our simple JavaScript file. And this is why we have, it's not a main or anything. We have to say, this is where to find it. So it'll go and find that code, and it'll begin to execute it. And in fact, inside it, it will also do some branching. I will ask a question about if those values that are put in the boxes are text values or are they number values. And I'm going to branch to the different options based on how that question is answered. We call that conditional branching. I want you to see something here. There's something more than simply a goto command going on in this JavaScript code. Later on at that programming camp, we learned about the idea of the subroutine. This was a block of code that you could call on from any place in your code, and when it was done, it returns you to the place where you left off in your previous block of code. What we call subroutines were later being called procedures or functions. In fact, I was driving to game night with a friend of mine the other day and started talking about this, and he said, yes, a method. And I'm like, yeah, he programs in Java all day, which is an object-oriented language, and when you think of functions in Java, often you think of methods. We'll talk about that a lot later on in our program. Now, code branching is simply the ability to control how we flow through the instructions that we give to our programs. The subroutines have a really nice feature at the end of them. They actually want us to return, and I mentioned this in the last video. They want us to return gracefully, and so we're going to have them end gracefully, which is what I did with the basic program as well. Just to consolidate the conversation here, branches usually occur based on some form of condition. We will talk about the use of conditional branching a little later on in this series. We'll also branch to subroutines or functions. The logical use of functions is to group often repeated sets of instructions, which lets us do more with less code. We write it once, we call on the function, and we can call it as many times as we need. But these functions are also used to separate blocks of code into discrete units of code. It's a way of differentiating our various different blocks of code, and that facilitates what we call unit testing, or the ability to test our code quite easily. We create these discrete blocks that are testable, and we just run our whatever we're doing in our language, where there's different ways of doing it, but at its heart, a unit test is just code you write to test a discrete block of code. And actually, we're going to talk about that in our next video. And just as the function uses a return statement to take us back to where it was called from, the program itself should also return us to the operating system, which is yet another set of instructions that are running on your computer. Even though branching is an important aspect of computer programming, it is something that can be done well or done not so well. And if you have too many branches or sub-branches in your code, it's hard to follow, it's hard to debug, it's hard to correct. And this happened a lot in the early days of BASIC with all these go-tos and go-subs. We, in fact, came up with a name for it. We called it spaghetti code. That's when your code is so filled with twists and turns that it's hard to trace through to find out where it is going wrong when it fails. Now, spaghetti is delicious, but not in a computer program. We'll talk more about how to avoid spaghetti code in the Programming Chops section of this series. So next up is this idea of code to test. We'll see you soon.